Hello, I'm Ben the Tutor, and I'm going to talk about the definition of a derivative today. So the first step is, what is the definition of a derivative? The limit definition of a derivative. Okay, so I'm going to begin by drawing a picture. We got some guy, some graph, and the question we are looking at is, how do I figure out the slope of that line, which is at a tangent at some point? I'm going to define this point here as x, and this guy is a function f of x. And so this y value can be found by plugging f of x in. And so I want to know what the slope of the tangent line touching there is. So I imagine another point over here, x naught. And the y value of that is f of x naught. And if I draw that line going between those 2 points, it is not the same slope. It is a different slope. But if I imagine bringing this point closer and closer in, every time I do that, the slope is going to get closer and closer to the slope at that point. And this is the definition of the derivative. The derivative finds the slope at that point. Okay, so you may remember this from lines. The slope is the rise over the run. And on a line, we might have these 2 points. And the rise is the y2 minus y1, and the run is x2 minus x1. That's the length of this line and the length of that line. So let's write the formula for this line in a similar way. Instead of the y's, I'm going to use the f's. So f of x minus f of x naught. So that's like y2 and y1 minus x naught. So that is the definition of the slope of that line. And what I said the derivative was when we take the limit as this x goes to that x. So the limit as x naught goes to x. Well, we usually write the other way, but that's okay. Fx minus x naught over x minus x naught. And that is the definition of the derivative. Now, the next question we'll ask, how do we use this? But before we do that, there's actually another definition of the derivative, and you need to know how to do both of them. So I'll show you the other one. It's a similar kind of idea. So if we draw the same kind of line here, and we draw an x like this, and that's my f of x. So my y value is f of x. And instead of picking another point there, I say, here's this little space, h. H is like an accordion. And so this point here is x plus h. And the y value there is f of x plus h. So the slope there has the same kind of thing. We go y2, f of x plus h. So x plus h is a point, 1 point, this point there. Or the x value in the point is that point there. And f of x, so that's that point, the y value at that point. Minus, or in the bottom, x squared plus h minus x. And here the x's cancel, so it's this y value, f of x plus h, minus this y value, f of x, over h. And here, the limit is what? The accordion is squeezing, so the limit as h goes to 0. And this is very much the same thing as this, but it just works out a little bit differently. Okay, that is the definition of the derivative type 1 and the definition of the derivative type 2. In the next video, we'll show you how to use the definition of the derivative.